Voyager 1, a spacecraft that has traveled farther than any other man-made object, has just sent back information that defies everything we thought we knew about the edges of our solar system. In a place known as the heliopause, Voyager 1 has detected something extraordinary, an impossible discovery that has left scientists both awestruck and perplexed. Launched in 1977 with the goal of exploring the outermost planets of our solar system, Voyager 1's mission was clear: collect valuable data and one day, perhaps, cross the invisible boundary that separates our solar system from the vast expanse of interstellar space. Voyager 1's journey has been one of groundbreaking achievements. After its flybys of Jupiter and Saturn, which provided unprecedented images and data, the spacecraft continued its journey into the unknown. In 2012, Voyager 1 became the first man-made object to officially leave the solar system, crossing the heliopause and entering interstellar space. But now, more than 47 years after its launch, Voyager 1 is surprising us once again with an unexpected discovery at the very edge of our solar system, something that no one could have predicted. The heliopause is the boundary that marks the end of the sun's influence, where the solar wind, which constantly streams from the sun, fades away, and the interstellar medium takes over. Beyond this boundary, space is almost a complete vacuum, with much lower particle density compared to the areas closer to the sun. But what lies beyond this mysterious boundary? What is out there at the very edge of our solar system? Until now, we have only speculated about what the region beyond the heliopause could hold. The heliosphere, which is the protective bubble created by the solar wind, shields us from many dangerous particles coming from the galaxy. It acts like a cosmic shield, protecting the planets in our solar system from the harmful radiation and energetic particles that are scattered across interstellar space. By crossing the heliopause, Voyager 1 has ventured into uncharted territory, and for the first time, we have been able to study this region up close. Now, as Voyager 1 sends back data from interstellar space, it has revealed phenomena that scientists have never before observed. One of the most puzzling discoveries is the fluctuations in the magnetic field. These fluctuations are unlike anything expected in the region beyond the heliopause, where it was believed that the magnetic field should be relatively constant. Yet, the recent data from Voyager 1 suggests that something unknown is occurring at the very edge of the heliosphere. These fluctuations are unlike anything scientists have seen before, and their presence raises significant questions about the nature of interstellar space. The idea that the magnetic field in this region should be constant is rooted in the understanding that once the solar wind fades, the space beyond should be relatively empty, with few electromagnetic disturbances. However, the data shows that this is not the case. The fluctuations in the magnetic field are being caused by some form of unknown activity, and scientists are struggling to explain them. What could be responsible for this phenomenon? Could it be some kind of energy that we have never before encountered or even detected? Or could it be that forces in deep space, far beyond our current understanding, are interacting with the edge of our solar system in ways that we cannot yet comprehend? Some scientists have proposed that these fluctuations could be a form of energy that is somehow emanating from the depths of the universe. They might be echoes or ripples from far-off events, such as explosions or cosmic events, that are traveling through space and interacting with the edge of our solar system. But the theories do not stop there. There is a growing belief that these magnetic fluctuations might be a response to some kind of external influence, a push from the far reaches of space. Perhaps something outside the solar system is interacting directly with our solar system, and the edge of the heliosphere is reacting to this interaction. This possibility opens up exciting new ideas. Could the edge of the heliosphere be responding to an external force that we are only beginning to understand? The signals from Voyager 1 are weak but consistent, with repetitive patterns that have never been observed before. Could these signals be telling us that there is something beyond the solar system that is directly influencing the space around us? Could it be that these fluctuations in the magnetic field are the result of some kind of cosmic force pushing against the solar system from outside? One particularly fascinating hypothesis suggests that the heliopause itself could be being squeezed by some kind of energy stream originating from the Milky Way or even from beyond. These energy streams could be created by stellar winds coming from nearby stars, or they could be the result of much more distant and as yet unexplained phenomena. If these energy streams do exist, they could have a significant impact on our understanding of how the solar system interacts with the wider galaxy. For the first time, we might be witnessing the solar system being connected to other parts of the galaxy by an invisible network of energy currents. If this hypothesis is correct, we could be on the verge of a monumental discovery, one that could radically change our understanding of energy and how it operates across the universe. Imagine if energy currents, like cosmic highways, connect different parts of the galaxy, creating invisible bridges between stars and solar systems. If such currents exist, they could allow for some form of energetic communication between distant points in the galaxy. This idea opens up entirely new ways of thinking about how the galaxy is structured and how energy flows across vast distances. It could provide the missing piece to understanding the fundamental architecture of the universe. For some scientists, this discovery is not just profound, it's a wake-up call. Voyager 1's findings are challenging everything we thought we knew about the solar system and its place in the galaxy. If the energy currents connecting the solar system to other parts of the galaxy do exist, it would suggest that the solar system is not isolated, as we once believed, but part of a larger, interconnected cosmic web. This realization could forever alter our understanding of how stars, solar systems, and galaxies are linked together. The Voyager 1 mission has been, without a doubt, a journey into the unknown. With every piece of data it sends back, Voyager 1 reminds us of how little we truly know about the limits of our own solar system. Despite the spacecraft's technology being outdated by today's standards, its mission continues to provide invaluable insights into deep space. Launched in the 1970s, Voyager 1's instruments were state-of-the-art at the time, but they are now far behind modern technology. Yet, it remains our best tool at the frontier of the solar system, providing us with unique observations that we cannot obtain from any other spacecraft. Although Voyager 1's technology is considered antiquated by today's standards, it continues to exceed expectations. The spacecraft is more than 23 billion kilometers away from Earth, yet it still sends back priceless data. Each signal it sends is like a distant call from a cosmic frontier, reminding us of how much we have yet to learn. Despite the enormous distances and the spacecraft's aging instruments, Voyager 1 remains our only witness to the phenomena occurring at the outer edges of the solar system. As it travels farther from the Sun, it continues to provide valuable data that could change our understanding of the universe. Voyager 1's discoveries are driving us to continue exploring the cosmos. The spacecraft has shown us that there is much more to discover out there, and it has sparked renewed interest in creating spacecraft capable of traveling even farther into deep space. Its mission, which has already lasted more than 4 decades, has provided us with a glimpse into the unknown. As Voyager 1 shows us the way, humanity prepares to take the next step in space exploration. With each piece of data that Voyager 1 sends back, we get closer to the day when humans might cross that boundary and explore the edge of the solar system in person. Perhaps, someday, we will venture beyond the heliopause and discover what really lies on the other side of our solar system. Elon Musk, one of the most influential visionaries in space exploration, has been closely following Voyager 1's breakthroughs and discoveries. Musk has long been fascinated by the possibilities of deep space exploration, and he sees Voyager's latest findings as a wake-up call for humanity. In his own words, Musk has expressed that this discovery could accelerate efforts to develop interstellar spacecraft capable of overcoming the current limitations of space technology. As the CEO of SpaceX, Musk has always had his sights set on deep space, and Voyager 1's latest data is motivating him to push the boundaries of space exploration even further. Could the information provided by Voyager 1 be the spark that ignites a new era of interstellar exploration? Musk believes that the discoveries made by Voyager 1 are proof that the universe is full of mysteries yet to be unraveled. This, in turn, has motivated him and other visionaries to pursue new technologies that could allow humanity to explore deeper into space. Musk has said that Voyager 1's findings remind us that we are just beginning to scratch the surface of the universe's many secrets. As Musk points out, we cannot rule out the possibility that unknown life forms or biological phenomena could be interacting with the solar system in ways we do not yet understand. While these ideas may sound like science fiction, every new discovery brings us closer to understanding whether we are truly alone in the universe. Each signal Voyager 1 sends back is another piece of the puzzle, and in the future, these data could help scientists uncover signs of life in interstellar space. Voyager 1 has crossed boundaries no other man-made object has ever reached, and it continues to teach us how vast and mysterious the universe really is. Even though Voyager 1's journey is nearing its end, the questions it raises will continue to resonate for years to come. It has shown us that the universe is far more complex than we could have ever imagined, and its discoveries will inspire generations of scientists and explorers. As we look to the future of space exploration, Voyager 1 reminds us that the journey never truly ends. Voyager 1, a spacecraft that has ventured farther than any other human-made object, has sent back a discovery that challenges everything scientists thought they knew about the boundaries of our solar system. This recent transmission from Voyager 1 defies expectations, providing data that has left researchers questioning the very foundations of space exploration. The discovery was made at the edge of our solar system, in a region known as the heliopause. What Voyager 1 has detected there is something so unexpected that scientists are calling it an impossible discovery. Launched in 1977, Voyager 1 was initially sent on a mission with a clear purpose: to explore the outermost planets of our solar system, gather crucial data, and, perhaps one day, cross that invisible boundary that marks the edge of the solar system and ventures into interstellar space. Voyager 1's journey has been a monumental one, full of groundbreaking achievements and discoveries. After its flybys of Jupiter and Saturn, which provided the world with unprecedented images and invaluable data, the spacecraft continued its journey into the unknown. By 2012, Voyager 1 became the first man-made object to leave the solar system and officially entered interstellar space, crossing the heliopause, the boundary that marks the end of the Sun's influence on the solar system and the beginning of the vast, uncharted territory of interstellar space. However, nearly 47 years after its launch, Voyager 1 has once again surprised the scientific community with a finding at the edge of the solar system, something that no one could have predicted. The heliopause is a boundary where the solar wind, which constantly flows outward from the Sun, slows down and eventually disappears. Beyond this boundary, space is almost completely empty, and the interstellar medium, particles and radiation from outside the solar system, takes over. It's a region that scientists had studied theoretically, but had never been able to observe directly until Voyager 1 reached it. The heliopause marks the outermost region of the Sun's influence, beyond which the solar wind vanishes, and the interstellar vacuum takes over. This transition zone is crucial for understanding the interactions between our solar system and the broader galaxy. As Voyager 1 crossed the heliopause and entered interstellar space, scientists had anticipated that it would observe the gradual fading of the Sun's influence and the beginning of the true emptiness of space. But what Voyager 1 has found goes far beyond expectations. The spacecraft has detected phenomena that scientists had not even dreamed of observing at the edge of the solar system. The most surprising finding is the fluctuations in the magnetic field, fluctuations that are unlike anything scientists had predicted. According to the current understanding of physics, the magnetic field in this region should be almost constant. However, Voyager 1 has sent back data indicating that the magnetic field is fluctuating, vibrating in ways that cannot yet be explained. The discovery of these magnetic fluctuations at the edge of the heliosphere raises several important questions. If the magnetic field should be stable in this region, then what is causing the fluctuations? Could there be a phenomenon at the boundary of the heliosphere that scientists have not yet been able to detect or understand? These fluctuations challenge everything scientists know about the solar system's boundary and the nature of space beyond it. Some scientists speculate that these fluctuations could be a form of energy that we have never before encountered or detected. They could be some kind of cosmic echo or ripple from the depths of the universe. For example, cosmic events such as supernovae or other powerful explosions could send out ripples through space that affect the space around our solar system. This idea, while speculative, suggests that the universe might be much more interconnected than previously thought, with waves of energy traveling across vast distances, reaching even the edge of our solar system. Other theories are even more intriguing. Some scientists believe that these magnetic fluctuations might not be the result of distant cosmic events, but rather the result of some external force interacting with the solar system. The signals from Voyager 1 are weak, but they show clear patterns, repeating themselves over time. This has led some researchers to propose that these fluctuations could be a response to some form of energy or force acting on the solar system.